Before we start our presentation, I just want to show you a few pictures of cars, such as this Mustang, this Challenger, and this Camaro. All they have in common, they're quite beautiful, but they use quite a lot of gas, and they damage our environment quite badly. And sadly, one day we will run out of oil. So we need something to substitute it. Hydrogen look really promising these days, with cars like this Honda. This is the first hydrogen-powered production car ever, and for more information, just watch the upcoming video.
This is the world's first hydrogen-powered production car. Its name is already infamous among car fans and keen greenies, and yet it's so elusive that most of us have never even seen one. Its fuel is hydrogen, not fossil, and its only byproduct is water rather than carbon dioxide. The Honda FCX Clarity is already a hero amongst eco-warriors, and appropriately the first batch to be made was leased to people in California, where being green is as fashionable as being rich. Indeed, Jamie Lee Curtis, the actress, was one of the very first people to get her hands on one. The Clarity is driven by a 100 kilowatt electric motor that turns the front wheels, so really it's just an electric car. But the interesting part is how the car powers that motor. Hydrogen from the tank is pumped into the car, where it mixes with oxygen from the atmosphere in a fuel cell stack which is located just between the front seats. An electrochemical reaction produces electricity which powers the motor, which then powers the wheels, and what's left over is hydrogen, now mixed with the oxygen, which every schoolboy or girl will tell you is H2O, which is water. So this car has zero emissions.
Okay, so you just saw a video on how a hydrogen fuel cell car works. But what really is a hydrogen fuel cell? Briefly, a hydrogen fuel cell works kind of like a battery, which converts chemical energy into electrical energy without any dangerous byproducts that are produced that can harm our environment. Now, to really explain what a hydrogen fuel cell is and how it works, I'm going to use the help of a series of diagrams. From left to right, here is an anode, a catalyst, a membrane, another catalyst, and a cathode. So the first step is the insertion of hydrogen. Hydrogen atoms are going to be inserted. Shortly thereafter, they're going to react with a catalyst, which is going to split the hydrogen atoms into positive ions and electrons. The electrons are not allowed to move through this membrane, so they will go through the electrical circuit and power the load. At the same time, the hydrogen ions are allowed through the membrane and will go to the cathode. So already we have produced electrical energy from chemical energy. Now, on the other side, on the cathode side, oxygen atoms are going to be split by the help of a catalyst into ions. And as we already know, oxygen has a huge negative charge. Therefore, it's going to react with hydrogen and electrons to produce water, which will come up. And these are the byproducts. So the overall reaction is hydrogen is converted into electrons and positive ions, which are thereafter going to produce water when react with oxygen. Is that okay?
Action.
So we just learned how hydrogen fuel cell work. And you also probably noticed that there are specific parts to it, such as an anode and a cathode. Each of these have specific half reactions that are associated with them. The anode half reaction represents oxidation. And in this case, it is hydrogen gas being split into hydrogen ions and 2 electrons. We also have a cathode part to it, which represents reduction. And in this case, we have 2 hydrogen ions reacting with half an oxygen gas and electrons to get water. Now, using the methods we learned in class, we can cancel terms that are on the both sides of the equations, such as in our case we have 2 electrons and also hydrogen ions that get cancelled out. Now, by adding the remaining terms, we get hydrogen gas reacting with oxygen gas to produce water. And this is in fact our overall reaction. Hydrogen reacts with oxygen to produce water, and also at the same time we get electrical energy. As you know, the hydrogen fuel cell has many applications. But what they all have in common is they have to get compressed liquid hydrogen from a hydrogen fuel station, such as one of these. As you might know, hydrogen is the most abundant and one of the most reactive elements in the whole universe. This means that you very rarely are going to see hydrogen by itself, because it's usually compounded with water or other hydrocarbons. And although the hydrogen fuel cell process itself is clean to our environment, how we get the hydrogen in the first place is what causes trouble. As of right now, the most popular way and most expensive way of getting hydrogen is by extracting it from, for example, water. This in turn needs fossil fuels, which will cause greenhouse gases and damage our environment. However, there are other ways to find hydrogen, which Amin is going to talk about later. And even if we did find a way to extract hydrogen without damaging our environment, it would be impossible to store, manufacture, and transport hydrogen without some of it being leaked into our atmosphere. Experts say that about 4 to 8 times as much hydrogen will enter our atmosphere if the hydrogen fuel cell becomes the most dominant energy source. You might ask, why is this negative? Well, if hydrogen enters the atmosphere, it will help deplete our ozone layer. And as a result, more ultraviolet radiation will strike the Earth's surface. And this in turn will cause skin damage to people.
As Sam explained, getting hydrogen from air is very tricky, expensive, and damages the environment. Therefore, scientists are looking for new resources. One of the promising sources of hydrogen is extracted from seawater. Experts in the University of California have developed a new catalyst that generates hydrogen from seawater. They prepared a sample of molybdenum oxide complex that can serve an electrolyte catalyst, reducing the energy required to generate hydrogen from water on the ordinary mercury electrolyte. Furthermore, molybdenum is much cheaper than previous metal catalysts, which make a huge difference in a large scale hydrogen production. Okay, the high cost of production and delivery of hydrogen has created a financial issue. Therefore, scientists have developed a hydrogen recovery and recycling device which can efficiently and, more importantly, cost efficiently recover and recycle hydrogen. This device utilizes a process whereby hydrogen is actively removed from mixture of different gases, producing a high purity gas, hydrogen gas, steam, while the rest of the gases pass through as waste. Hopefully, this will encourage more manufacturers to use hydrogen as their main fuel, which help us to have a greener planet. Okay, the efficiency of hydrogen fuel cells is based on the amount of the energy drawn from them. Drawing more power means using more current, and using more current requires more hydrogen. So as a general rule, we can say the higher the power or the current is, the lower the efficiency will be in hydrogen fuel cells. And also, the maximum power, the maximum efficiency of hydrogen fuel cells at room temperature in an ordinary situation with the ordinary fuel cell is around 83%, which is a very, very respectful number comparing to, say, fossil fuels, which is only 37%. And also, they create quite a lot of greenhouse gases, which hydrogen just creates water.